In this video, we are going to learn about again simplifying trigonometric expression. But in this trigonometric expression, there is a new thing to learn. I will explain you now. But in this expression, please do not use secant x identity, because if you will use secant x identity, your expression will become really complicated. So what are we going to do? Look at this. This expression have two fractions, and again, whenever you have two fractions, we will try to make same denominator. We don't have same denominators are different, so we are going to making same denominator. So what we will do, denominator of this term we will multiply for this one, and it's going to be cos x over secant x plus 1. I am going to multiply this term with denominator of the other one. It's going to be secant minus 1 and secant x minus 1. Okay, and now for this term I am going to multiply this denominator, and also I am going to divide. We have cos x over secant x minus 1, and I will multiply with secant x plus 1 over secant x plus 1. Okay, now let's simplify this. It's going to be secant x minus 1 cos x over secant x minus 1 secant x plus 1, plus this is going to be cos x secant x plus 1 over secant x plus 1 and secant x minus 1. So what are we going to do next? Next we will make some simplification in this expression. Look at in numerator. Before numerator, let's look at the denominator. You can see that denominator is similar, right? Now if the denominator is same, we can combine the two fractions, and this is going to be same denominator. It's going to be secant x minus 1 secant x plus 1. Okay, and in the top part you can see that it's multiplication. You can multiply this term with this term with this one, and for the right term you can multiply this with this and this with this one, correct? And it's going to be secant x cos x minus cos x plus cos x secant x plus cos x, right? Now in this question, what is different? We are going to use an algebraic formula, which is right here. I'm going to write it down here. A squared plus, sorry, not plus, minus b squared, that is equals to a minus b, a plus b. Now if you look at the denominator, the right side of this formula is like a denominator. The denominator we have right now, it's same. Now look at this. Secant x is presenting a minus 1 is presenting b, right? Now here again secant is a plus and a is presenting b, but a minus b times a plus b is equal to what? A squared minus b squared, right? I hope you guys understand this one. So I am going to use this formula in our expression, and this will become top part. Let's see the top part. It will become negative cos x plus cos x will cancel out each other, and this is going to be secant x cos x plus cos x secant x, correct? And denominator will become secant squared x minus 1 squared, correct? All right, now look at the numerator. This numerator will, I'm going to use identity on secant, so it will become 1 over cos x times cos x plus cos x times 1 over cos x, and denominator will be secant squared x minus 1, because 1 squared is 1. Okay, now cos x cancel with cos, this cos x cancel with this cos 1, and you will have 1 plus 1 over secant squared x minus 1. Clear? Now look, in denominator we are going to use an identity. What identity? You can see that secant squared x. We are going to use Pythagorean identity, which I am going to write down for you, and that identity is tan squared x plus 1 is equals to secant squared x. And when you will rearrange this identity, it's going to be tan squared x equals to secant squared x minus 1. This identity I will use here, and it's going to be 1 plus 1 2 over tan squared x. And we know that cot x is equals to 1 over tan x, correct? And this 1 over tan x will change into 2 cot squared x. This is the simplified form of our given expression. Alright, so now we are going to talk about this question. 1 minus cos x over tan x plus sin x over 1 plus cos x. Okay, again we have two fractions, and to simplify two fractions we will combine the denominators. Okay, so to combine the denominator, I will multiply first in with the first term the second denominator, and it's going to be, this is our term is, okay, and I will multiply with 1 plus cos x, and I will also divide with the same term 1 plus cos x. Okay, second term I will multiply with the first denominator, and it's going to be sin x over 1 plus cos x multiply with tan x over tan x. Now we have same denominators, we will combine them, and it's going to be 1 plus cos x 1 minus cos x plus sin x tan x over 1 plus cos x tan x. If you remember, in this video, in the past question, I explained you that when you have this expression 1 plus cos x 1 minus cos x, we will use that formula that a squared minus b squared equals to a plus b, a minus b. By using that formula, this part of this question is going to change into 1 minus cos squared x plus sin x, and now here you have tan x. On tan x, now I will use identity, and we will get sin x over cos x. Clear? Alright, we have 1 plus cos x and tan x in denominator. I will keep it 1 plus cos x. Tan x is sin x over cos x. Clear? By using Pythagorean identity, I hope you guys still remember that sine squared x plus cos squared x is equals to 1, and then sine squared x is equals to 1 minus cos squared x. This identity I'm going to use for this expression, and it's going to be sine squared x plus, simplify the next part, sine squared x over cos x over 1 plus cos x sine x over cos x. Okay, if you are writing over cos x under sine x or everything, it's same thing. All right, now what do we do next? Look at in numerator. In numerator, we are having two different fractions, right? Like this. Now we are going to combine this same denominator, and to make them same denominator, we're going to multiply with cos x to this term, and here you're going to have sine squared x over cos x as it is. You will keep the denominator over cos x. Clear? All right, now the top part, numerator, will become cos x sine squared x over cos x plus sine squared x over cos x, and numerator I'll still keep it over cos x. Next, what are we going to do? We are going to combine the denominators in the numerator. Cos x sine squared x plus sine squared x over cos x. One plus cos x sine x over cos x. Now look at this. This cos x will cancel out each other, and you will left with cos x sine squared x plus sine squared x over 1 plus cos x and sine x. Clear? What are we doing next? In numerator, we are going to take sine squared x as a common factor, and you will have sine squared x cos x plus 1 over sine x 1 plus cos x. This is cos. Now look, cos x plus 1 plus cos x, it's same thing, so we will just cancel them out. Sine squared x over sine x, they will cancel out each other, and you will left with only sine x. This is the simplified form of your expression.